Students, today we are going to see the program Implement and Analyze NQ's problem. So what is NQ's problem? NQ's problem is given an n by n chessboard where we need to place n cues in such a way that there should not be any row-wise, column-wise and diagonal-wise conflict. That is NQ's problem. So NQ's problem is implemented using backtracking technique. So using state space tree, in backtracking using state space tree, we can find out the solutions for the NQ's problem. Now, how it is implemented? It is implemented here, as I told, it's using backtracking technique, and we are using recursive functions to implement NQ's problem. So we'll just go through the program once. Yeah. So to implement NQ's problem, there are multiple user-defined functions are used. The first one is Qn function. Okay. Now, enter the number of queues. See how many number of queues you are going to place. If you are having 4 queues means it is becoming a 4x4 chessboard. If it is 5 queues means it is becoming a 5x5 chessboard. So how many number of queues? For example, 4 means 4x4 chessboard. So we are entering that value in n and I'm calling the function queue. Queue 1 comma n. That means I'm going to place the first queue. I'm going to call for the first queue. Okay, queue 1 comma n is the function. So I'm going to place the queue in the first row. So the function is defined. This queue function is defined here. So in row comma n. So a row is 1 now. So we are going to place the queue in the first row. When I'm going to place the queue in the first row, I need to decide that in which column I can place the queue so that there should not be any conflict. So we'll check one by one column. Okay, whether I can place row number 1, column number 1. If it is possible, we can place there. Otherwise, row number 1, column number 2, row number 1, column number 3, etc. We are going to check it, whether we can place it. So for checking whether you can place in column 1, 2, 3, etc., we are calling another function that is place row comma column. Now in the first iteration, it will be place 1 comma 1. That is whether you can place the queue in the first row and first column. So the place function is defined here. The place function is going to check whether is there any column conflict and whether is there any diagonal conflict. See, actually row conflict will be rectified when you're calling the function itself. I'm calling 1 comma n. That means I'm calling first row. For the first row, I'm calling. Next time when the function is called, it will be called for the second row. So when the function call itself, the row conflict will be checked. The column conflict and the diagonal conflict will be checked in this place function. So it's like checking this function. If board of I equal column, this is the column function. If this is matching, then it is like return 0. There is a conflict, you cannot place it. And this is going to check the diagonal conflict. Again, if absolute value of board of I minus column is equal to absolute value of I minus row, there is a conflict. This will be return 0. You cannot place the queue in the column 1. So next we will be checking for the column 2 and so on. If there is no conflict, it is directly returning 1. So if it is returning 1, okay, you can place that particular queue in that particular column and the row. Okay, if row equal n means all the queues are visited. Okay, otherwise again this recursive call will be happening. Now, if all the queues are placed, then you can call the print function. So print function, here it is defined so that we can print that in that particular chessboard format. Now, if still queues are pending means again we'll call for the next one, row plus 1 comma n. So next time it will be 2 comma n and again the entire procedure will be happening. Now we'll see the execution. A program is copied here. Okay, program is copied here. When I'm executing running the program, it is asking how many number of queues. For example, I'm giving a 4 number of queues. So it will be a 4x4 chessboard. You can see the output, how the print function is working. So for the number of queues, there will be two solutions. Okay, this is the solution 1. First queue is in the second column, second queue is in the fourth column, third queue is in the first column, and fourth queue is in the third column. Similarly, for n is equal to 4, we are having one more solution. That is, first queue is in the third. It's a mirror image. First queue is in the third column, second queue is in the first column, and third queue is in the fourth column, and fourth queue is in the second column. So this is the NQ's problem. So execute NQ's problem, go through the program.